So now that you know a little bit about the concept of atomic operations in general, let's dive down and talk about Java's support for atomic operations and atomic variables. And it turns out that there's quite a nice collection of such capabilities. There's several types of atomicity that are supported in Java, and you can learn more about that at the link at the bottom of the page here. One type of mechanism, which we're not going to talk about right away, we're going to probably come back if we have time, it's not as important for the assignment that we're doing, is something called volatile variables. And we'll probably cover it before the class is done, but I'll just give you a quick overview here and you'll be aware of it. It's a very simple concept. The concept of a volatile variable is if you mark a field as volatile, that means that reads and writes to that field from whatever thread you're doing in a process, whatever threads you're using in a process, will go directly to main memory and do the read atomically or the write atomically from main memory, thereby bypassing any local processor core cache. So it's kind of like playing Monopoly. Go directly to go directly to jail. Do not pass go. You don't stop at any intermediate phase. You just go directly to and from main memory. And here's a good example of where you need to use these mechanisms. And this is just like ridiculously subtle. So this is an example called ping pong test, kind of like we talked about the ping pong wrong stuff. And what it wants to do, or actually what this program does, because it's correctly written, is it wants to alternate printing ping and pong between threads T1 and T2. And if you want to try this yourself, you can go to the folder I show here, my EX31 folder in my GitHub repository, and you'll see how this code works. So we're going to create two threads. One thread is going to be the listener thread. The other thread is going to be the changer thread. So it's T1 and T2. We start both threads. And notice that we define the field that these two threads share, we call val, as volatile. If we take volatile out, if we don't have volatile, then this program may never terminate because the value of val will not be pushed between the threads, will not have them be made visible. And so we'll end up with inconsistent results. And so defining val as volatile means that reads and writes bypass the local cache and they go directly to memory. And so what we're doing here is we're showing some examples where the listener thread is going to be reading the value of val, that shared field, atomically. So it's guaranteed to get the latest version. And down here, the changer thread is going to be writing to val atomically. And by doing this, everything works as desired. And if you want to try this, go and try it, see how it works if you run the program using the volatile keyword. It should work properly and do ping pong in an alternating way. But if you take out volatile, you'll get strange results. There's also a pile of very low-level atomic operations that are defined in something called Java's unsafe class. And the names should sort of give you a hint that don't try this at home. This is meant to be used by people implementing the Java class libraries, not by people using the Java class libraries. So in fact, the unsafe class is sort of hidden from you. You don't get to access it directly, although you can use its capabilities through the Java atomic classes we're going to talk about shortly. So again, this is not meant to be used by mere mortals. It's meant to be used by the Java class library developers like my good buddy Doug Lee, who wrote most of the Java concurrency packages. The most important methods that are in Java unsafe for the purposes of atomic discussions that we're having here are the so-called compare and swap methods, or CAS, as it's often known. So CAS is just the acronym for compare and swap. And we'll talk a bit more about compare and swap. You should know how compare and swap works because it's likely to be a quiz question at some point. But basically what it does is it atomically compares the contents of a memory location with a given value and modifies that value atomically to a new given value if and only if they're both the same. And I will walk through this code later in more detail to tell you how it all works, but that's basically what it's doing. You can use these CAS methods, or maybe not you, but people who implement parts of Java can use CAS methods to implement what's known as lock-free algorithms or non-blocking algorithms. And all this really means, lock-free just means that you're never going to wait on something. You're not going to block. You're going to spin. And of course, that will be very important when you do assignment 1B. So we'll see here that there's two very simple examples here. This is something we'll talk about in more detail when we get into the nitty-gritty of how Java's atomic classes work. But basically, the basic idea is there's a lock mechanism, and what that does is it sits there in a tight loop, spinning using the compare and swap int method to check to see if a field has a certain value. In this particular case, if it's got the value 0, and if it does have the value 0, it will automatically set it to the value 1. And that's lock, because we're changing it from 0, which means available, to in use, which means it's not available. It means it's locked. And unlock, as you can see, similarly, will set the location to 0. So basically, that's releasing it, if you will. Now, again, this is kind of C-like code. I'm sort of punning between C++ and C and Java here, but we'll go into more detail and look at how this works. But conceptually or logically, that's what's going on. Of course, the way it's really implemented under the hood is in hardware, but the operations that are exposed are using these methods called compare and swap. And there's compare and swap int, compare and swap long, etc. The synchronizers that are implemented in Java's class library use the CAS methods extensively. And if you want to see an excellent video, please take a look at the link at the bottom of the slide. This is by my friend Doug Lee, who I've known since 1985, just an absolute genius at object-oriented programming and concurrent programming and parallel programming and software patterns. And he wrote large chunks of the Java concurrency libraries. And he's also a professor at the State University of New York in the Oswego campus. Fantastic guy. Another set of capabilities that are exposed, and these are actually the things we're going to talk about, the things we're going to use in our assignment, are the atomic classes. And as you can see, there's a bunch of them: atomic Boolean, atomic integer, atomic long, atomic reference, and so on and so forth. Internally, these classes use the Java unsafe mechanisms, in particular those compare and swap operations we looked at, to implement a bunch of lock-free algorithms. And good examples would be atomic long and atomic Boolean, and we'll talk more about these different types of atomics here shortly, and I'll walk through some examples. But for your first assignment, the undergrads are going to need to know how to use atomic Boolean, and the grad students are going to have to learn to use something called atomic reference. They behave very similarly, just work on different data types. So that's the end of the overview about Java atomic operations and variables. We're going to focus again our attention on the atomic classes. And if we have time, as time permits, we'll come back and talk about Volatile later. Volatile is interesting, but very simple, and we don't need to know it as well in order to do the programming assignment.